Hello guys, in this video we will implement another type of RNN language model. We'll consider the same text, that's the first paragraph of the Jack Angel poem, and then we will ask RNN to learn. But in this video we will try to make it learn in a different way. Alright, in my first part of this implementation I had actually trained RNN with the architecture of one in, one out. One in, one out, right? So one word for every one word input. So this is how we implemented it. So input X, this is our RNN block. We had the dense layers and this will be the output, right? So this was our initial model. Now, and this did not actually give us the desired result. The accuracy was around 87.5 something, right? 87 or 89.5. But in this video, we will alter the learning process of RNN. So it will be two words in, one word out. Okay. So for every output, we need two words as input. So it will be like this. So X1, X2, and then I'll have my Y hat. Okay. So this will be my implementation right now. So the sequence will be word 1, word 2, this will be my input, and then I will have my outputs. Okay, I have to train the data, I have to train the model by preparing the data in this way, X and Y. So I need the input and the actual Y, okay, so that I can train my model. Okay, so let's start. So before actually implementing the model, we need to prepare these sequences, what I told you, right? So we need to prepare all these things. So what we'll do, we'll first prepare the sequences required for this particular type of model, two words in, one word out. So we already have this encoded variable with us, so which has already encoded the data. So this is our data, encoded these words into numbers by using Keras tokenizer. Okay, so these are our encodings. Now what we'll do, we'll create the sequences using these encodings. So what I'll do, I'll say I'll create a variable called sequences. It will be of type list. Okay, then I will append the sequences to this list as desired. So two words in, one word out, right? So first two numbers will be input, the third number will be output. Then we will separate out X's and Y's from this sequences list. Okay, so let's start. So what I'll do, for I in range of 2 comma length of encoded, right? So the variable name is encoded. Then what I'll do here, I'll say sequence is equal to encoded of I minus 2 to I plus 1, right? And then sequences dot append sequence, right? So what this does, so initially I is at second place. So 0, 1, 2, it's pointing to 3. Then what I'll do, I will go 2 steps back. It will be pointing to 2. 2 to I plus 1. 2 to 3. 0, 1, 2, 3. So I want 2, 1, 3 as my sequence, wherein 2 and 1 will be the input, 3 will be the output. Okay. So like this, at the next iteration, I will be equal to 3. So I want 1, 3, 4 as my sequence. So 1, 3 will be input, 4 will be output. Then 3, 4, 5 as my sequence. 3 and 4 will be input, 5 will be output. So something like this, right? We want something like this. So now if I execute it and then if I check my sequences, I'll have my sequences ready. Okay. Hope this is clear. So these first two things are my X's, these are my Y's. Okay. Now that we have this, we will separate out our X and Y variables. So how we can do that? First, let me convert it to NumPy array so that it will be easy to operate it in that on top of that array. Okay. So X comma Y is equal to sequences of, I need all the rows. Okay. And then what I need first two columns, correct? So I need all the rows and then I need first two columns, correct? So how I can write that? It will be 0 to 0 is the first column. I need first two columns, right? 0, 1, 2. So I'll say 2, right? So this is one part. Then Y will be sequences of I need all the rows and the last column. I can either say -1 or I can say 2. So if I execute this, if I check my x, it will be 2, 1, 1, 3, 3, 4, 4, 5. Okay. And my y's will be the last column 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 2, 14, 15. So if you check here, 2, 14, 15. So it's matching, right? So now we have separated out x's and y's. Now similarly, as we did in my part 1 video, let's check the length of my sequences. So this is 23. So we have total 23 sequences to train. So it's a small data set, right? So we will train the model on these 23 sequences, and let's check if it is able to learn the poem. Okay. So that's our idea, that it should learn if we implement this particular model, 2 words and 1 word up, right? So let's do that. Now we know that we need x in the form of 3-dimensional array as an input so that we can feed it to our Keras RNN model. So right now x is of 2-dimensional shape, right? So if I check x dot shape, it will be 23 cross 2, correct? So what I'll do, I will convert this x into 3-dimensional array. So how I can do that? I'll say x equal to x dot reshape. So what it will be, to have it in a dynamic fashion, it will be x dot shape of 0, 2, 1. Correct? Why this 2? Because it has 2 columns. So if you want this also to be in dynamic fashion, it will be x dot shape of 1. Okay, and then 1. So now if I check my shape of x, it will be 23, 2, 1. Okay, so now we have our x. Another step before we actually feed these things to the model, we need to one-hot encode the outputs. Okay, so our y is 1-dimensional array, so we will convert this into one-hot encoded vectors. Okay, so each of this will be converted to one-hot vectors, right? So since we have vocab size of 21, so how I got to know that? It's tokenizer dot word index, and if I check the length of this, it will give my vocabulary. Okay, so we have 21. Now let us encode this into one-hot vectors. So how I can do that? It will be Keras dot utils dot to categorical. It will convert this into categorical array. So this will be converted into one-hot encoded vectors. So if I check this y, I'll have this. Now as we have seen in my first part of this video, if I check the shape of this, it will say 22. Why? Because to categorical will by default create the index for 0, index 0, which will not be assigned to any word in the dictionary, in the vocabulary that we have. So we'll have to take care of this during our model training. Okay. So now that we have our x and y's ready, let us create a simple RNN model. Okay. So how we do that? So it will be similar to, let me copy the same model that we have trained earlier. So model equal to sequential. Let me copy this in one notepad here so that I can paste everything at once. So it will be model equal to sequential, and then I will copy this. Okay. What I'll do, I will just paste it here. So now I have my models created, the model created. But if you look at the input shape, it's not matching, right? X is of shape 23, 2, 1. Each input is of shape 2, 1, right? So we have to change this to 2, 1. Okay. So let's first try with only single RNN layer. Okay. So let's not go with this, because I feel this should do a good job, because we are passing in more than one word as input to predict the third word, or just one word. Okay. So let me not return the sequences here. Then I'll have my dense, it will be vocab size plus 1 and activation as softmax. Okay, so let's see if this gets created. Model dot add. So it's taking a while. Let's wait. It says vocab size is not defined. Okay, so we have to create a variable. So I just showed you the length of this, but I have to create a vocab size, right? So let me vocab size, create a variable. Now if I do this, it should be all right. Okay, now let me check the model summary. You see, it has total 1814 params to learn. So again, just to refresh, we already know how we got 1088 params here, right? I have explained it in my first video, but just to refresh, I'll tell you it here. Okay. So how it is 1088. So we have input X, we have this RNN block. It has 32 units, this, right? So these are 32 units. And then we have the dense block connected to this. It is of 22, vocab size plus 1. Why this is 22? Because two categorical function or two categorical method of Keras will assign a default 0 index to the, it will create the 0 index, but it will not assign it to any word. So we will have vocab size plus 1 one-hot encoded vectors length. So that's why we'll have this vocab size plus 1 outputs. So now what are the weights associated with this? This will be 32, right? It will have 32 biases. So this will be 22 by 32, right? If you add it up, so let's see, and this itself will have 32 by 32 because this is the feedback loop, right? So it will have this. So if we add this up, so it will be 32 plus 32 into 32 plus 32 biases plus 22, so into 32. So till here it's RNN models weights, this RNN to dense layer weights. Okay. So if you just add it up, so let me just quickly go to calculator. 32 into 32, 1024 plus 32, 1056 plus 32, 1088. Right. So this is our RNN model parameter, which is 1088. This is correct. Okay. Then we will have this 22 cross 32, 22 cross 32. It will be, sorry, it's getting added there. 22 cross 32, 704 plus we will have 22 biases because we have 22 neurons in our dense layer, right? Plus 22. So it's 726. So hope you all are clear how to arrive at the number of parameters that we have in our neural networks. Any neural networks, you can compute the parameters like this. Okay. So now that we have this, our model is ready to get trained. So let's see how this does. If this doesn't do good, we will change the model architecture again and see how we can improve the performance. Okay. So let's see. First of all, let's try this simple model. So I'll say model dot compile. I'll again go with the same loss. It will be categorical cross entropy. Okay. So this will be my loss. Optimizer, I will again go with Adam optimizer. Okay, and then for matrix I'll stick to accuracy. So now I'm compiling my model, then I'm ready to train my model using the method fit. So what it will take, x comma y, and it need number of epochs. So first let's train it with 100 epochs. I want the explanation on the output. So let's see. It says positional argument follows the keyword. Matrix is equal to, it should be equals to. Okay. Now it's training. So let's see how it performs. Is it learning? Yes, it's learning. Okay. With 100 epochs, the accuracy is not that great. So let me increase it to 500. Okay. So let's see. Okay, accuracy is not bad. 82. Okay. Okay, I think we have surpassed our previous accuracy. I think it was 85 something, if I'm not wrong. Right? So, yeah, I think it was 85 or 87. Yeah, I think it's 87. Okay. So we have crossed that 87. We have improved a lot. So let's see by just increasing the epochs, because unnecessarily increasing the complexity of the model doesn't help always. It may try to overfit. So let's see if we are able to increase the accuracy. So the loss is getting reduced, no problem, but accuracy is stuck. Okay, so the loss is now getting oscillated. I believe 2030. No, it's further getting reduced. That's good. Okay, so I wanted it to be more than 95%, something like that. Maybe we'll not be able to achieve that with this particular model architecture. So what I'll do, I will, I'll try to, I'm just thinking what I can include further in my model. So whether it needs to be another RNN layer or how it should be. Okay, let's try with just a dense layer first. Okay, so let me again initialize it. Now the parameters will increase because I have added another dense layer. Okay, now let's try with 1000 epochs. We'll see, okay, how it performs. Is there any luck? No, I don't see accuracy getting increased. Okay, yeah, I can see it in getting increased now. Okay, so I think we have some better performance, if not 100% accurate. The loss is getting reduced greatly. So maybe if we wait for some more time and increase the epochs, we may inch towards higher accuracies. Okay, but for demo purpose, this is good enough. Okay, so now that we have trained our model, let me see how the plot looks like. plt.plot. So, oh, okay, I did not save it in a history, guys, so sorry for that. I'll just store the training history in a variable. So for that, again, I need to initialize. So this is the problem. If I forget something, I need to come from the top. So I'll be back once the training gets complete. Okay. Okay, so the training is complete. Now I am storing the history of the model training. Okay, so I just wanted to do that so that I can uh, plot the accuracy and loss curves. So how I can do that? I can say history of loss. If I just check this, okay, see, the loss is still getting reduced. It's not flat, right? So we can still go on training this network by increasing the epochs. All right, so in this case, what we did not need another RNN layer. We need not stack on top of that. So we just added another dense layer, so that just to increase the model complexity, so that this model could learn some non-linear patterns in the data, right? So that helped us, and it still has ability to learn. You can see it's not plateaued here, it's not flat, so it's still reducing, but it may get flattened as we go on training for higher number of epochs. Okay, so now just have a look at accuracies. History of accuracy. Okay, see, it's almost near to 100%. It's not 100%, it's 95%. So we still have 5% room to improvement. Okay, so now that we have seen this, we can test out our model. So how we can test it out? Let's test out the model. So now that the model is saying, okay, I'm ready, I have learned the poem, we will quiz it to check how well it has learned, right? So we'll treat this as a school for that particular model. So let's just display the data here. So this is our data, and if we ask the model by giving the input as what comes after Jack and, so it should say Jill. So if we say what comes after went up, it should say the, right? So similarly, if we say what comes after a pail or pail off, it should say water, right? So let's see if it succeeds in that. So for that, let me just say in text. So whatever you want. So let's take some random. Maybe this part Jill went. Then we can try with something else. Okay. Just will check what happens if we input this. Okay. In text. So now, since this is a text, we want this to be in a numerical format, right? So how I can do that? Or I have already have a ready tokenizer which has tokenized the sentence, so I'll just make use of that. Text to sequences, and it will take a list of text, list of sentences. Okay, and as you all know from my previous video, it will return a two-dimensional array. I just want encode it to be one-dimensional array. Okay, so now I have this. What I'll do, I will convert this to numpy array. Okay, now that I have this converted this into numpy array. So if I just check this shape, all right, encoded, so it's not three-dimensional, right? So it is a rank 1 array, so it just has two values in it. So I want this to be converted into three-dimensional array. So how do we do that? And what should be the dimension? It should be one input, shape of the input is 2, comma 1. So it should be 1, comma 2, comma 1, right? So let's reshape this. Encoded is equal to encoded dot reshape. So how it should be? 1, comma encoded dot shape of 0, right? Comma 1, right? So this is how our input should be. So now if I check my encoded dot shape, it is 1, comma 2, comma 1. Now we are ready to feed this into our trained model, and it is stored in the variable model, correct? Now let's see that. So I'll say y hat is equal to model dot predict classes encoded. Okay, so that's it. So it will predict. Okay, so what it says, okay, I had told you guys we will make use of this particular suggestion, right, in order to do away with this warning. So I'll just predict this. I'll just copy this and then I'll save this. Instead of x, it's encoded. Sequential object has no np model dot predict. Sorry. So let's just check the one. Okay, now it did not even give the warning. Anyway, right? So if I check the y hat, it will be 5. So this is my output for this encoded input. So the input is 3, 4. The words represented with numbers 3, 4. For that, the output is 5. So now let's see what this word 5 is. So how we can get that? We can get that from tokenizer dot word index, right? So it's a dictionary, right? So for 5, it's up, right? So if we check the data, input is 3, 4 and output is 5, right? Input is 3, 4, output is 5. So Jill went up. So is that the case? Yes, Jill went up. So it has given the right answer for this particular in-text Jill went. So now what I'll do, I'll copy all these things in one single cell so that I need not execute one cell by one cell, right? So I'll reshape this. We will check for multiple input text just to cross check its learning. Okay. Then I'll have my predictions. And for this, let me just for word, let me just say word comma index in what it is, tokenizer dot word index, right? Dot item. So it will give me a key value pairs. It will give me key value pairs, right? Then if index is equal to y hat, print that word. So now it's up. If I give came tumbling, came, is this a sequence, came tumbling or no? Let's check the data. Yes, came tumbling is a sequence. If I say came tumbling, it will be say after, right? So it seems that the model has learned this first paragraph of the poem Jack Angel went up the hill with this particular architecture, 2 words in 1 word out. Okay, so let's check for one more thing, then we'll wind up the testing. So a pail, so let's give this a and pail. So let me say a pail, it should be off. If I say pail off, say water. Okay, so it is doing a great job in filling up the blanks that we ask by giving it two preceding tokens and asking it to predict the next coming token. So this is how you train a simple language model in RNN for a data set. So this model complexity goes on increasing as and when the data set increases. So we just had 21 size vocabulary. So in total we had just 21 words to learn out of it. So it did a decent job with a simple RNN model, right? So that's it for this video, guys. If you have any questions further, you can reach out to me, or if you want me to implement something else, please don't hesitate to ask me in comment sections. I will be happy to do that. Okay, maybe I'll come live if you guys request, and then I'll do the live coding in front of you, so you can learn as I code. Okay, so that's it for this video. If you haven't subscribed to my channel, please do subscribe, and if you like the content, give it a thumbs up and then share with your peers so that they will also be benefited. Okay, so thanks again. Till we see you in the next video. Bye bye.